Okay, section 5.4. Here's the formulas, and you're given these on the formula sheet. 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. One-half cosine alpha minus beta plus cosine alpha plus beta. 1/2 sine alpha plus beta plus sine alpha minus beta. And 1/2 sine alpha plus beta minus sine of alpha minus beta. All right, and you do need to, if I ask you to use these formulas, you need to use them even if there's an easier way or a different way. You need to follow the directions. So all you need to know is how to use these formulas to express the product as a sum or difference. So now we have a product, we want to express it as a sum or a difference. So we have two sines multiplied together. This is alpha, this is beta. So it's the top formula. It's going to be 1/2 cosine, and I'll fill that in, minus cosine. So this first one was alpha minus beta. The second one was alpha plus beta. Copying it carefully from the formula sheet. 5x minus 2x, 5x plus 2x. So that simplifies to 1/2 cosine of 3x minus cosine of 7x. And that's the answer. Expressed as a the product as a sum of difference. All right.
So why couldn't you do cosine like negative 4x? You know what I mean?
Why couldn't you do?
Why couldn't you do one more?
Why can't you do one more step?
Yeah.
Because you can't. You can't do that. You try it with regular angles. If you have cosine 60 degrees minus cosine of 30 degrees, is that cosine of 30 degrees?
Gotcha. Okay.
Okay. So think about an example like that when you start thinking. Yeah, sometimes you guys go too far.
Now, if you had cosine 8x minus cosine 7x, would you do cosine x, or would you just?
No.
Okay.
No. See, you can't combine the insides of the cosines like that. No.
Oh, I see. Okay.
You can't do
I
that.
see. I understand now.
That's so. All right. So if you had cosine of 60 degrees minus cosine of 30 degrees, you're saying that would be equal to cosine of 30 degrees? Well,
I think I was just thinking more so, like if they had cosine 40 degrees or 45 degrees in the last chapter, you know how we broke it down to cosine 30 plus cosine 15 or something, you know what I mean?
okay. Well, you're just making it way too complicated, I think.
Okay.
Okay. All right. So we can't combine those, but that's a good question. It's probably a common mistake. All right. The next one. This is all inside the cosine. I like to put parentheses sometimes here. Same thing, except now we're going to use the cosine formula. So I'm going to write the formula right here. It's cosine times cosine. So just to have it right above us, 1/2 cosine alpha minus beta plus cosine alpha plus beta. So our alpha is 7x, our beta is x. So this is going to be 1/2 cosine of 7x minus x plus cosine of 7x plus x. Now you do combine your terms inside the parentheses, and you get 1/2 cosine 6x plus cosine 8x. And that's your answer. That's as far as you can go. So you'll be given the formulas and you'll be asked things like this, and it'll tell you to use, you'll have to know the names of the formulas though. You'll have to, I don't remember. You look at the formula sheet and see if it says the names. You have to use the right formula. Okay. Sum to product formula. So these are the sum to product formulas. Most high school trig class, or some of them make you memorize all these things.
That would be absurd.
So if you read the book, it keeps telling you clues on, how to memorize them. And this is 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. This is -2 sine alpha plus beta over 2 sine of alpha minus beta over 2. All right. So now you want to express the sum as a product. You're going to use these. We've got a sine plus a sine, and so you can't say that this is sine of 10x. You've got to use this formula. So sine plus a sine is this formula up here. It's probably a good idea to write it down on your paper right above what you're working with. So I'll write this. 2 sine, and this will be my alpha, this will be my beta. 2 sine alpha plus beta over 2 cosine alpha minus beta over 2. So replacing alpha with 7x and beta with 3x, we get 2 sine 7x plus 3x over 2 cosine 7x minus 3x over 2. Simplify that. 10x divided by 2 is 5x. And 4x divided by 2 is 2x. That's your answer. The last one is the sum of 2 cosines. So I'm going to copy the formula down. Of course, this is my alpha. This is my beta. 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. Some of you copied the formulas down wrong when you did those worksheets, so you just have to be really careful. It makes a difference if there's a minus sign. I did grade that worksheet you turned in last time, and posted the solution. So you should be looking at those and making sure you're understanding this. 2 cosine of 3x plus 2x divided by 2 cosine of 3x minus 2x divided by 2 is 2 cosine of 5/2 x cosine of x. We could say over 2 or 1/2 x. I could have said 5x over 2. Doesn't matter. I feel the notes similar, but I could have wrote 1/2 times x. So that's it. That's all you. That's what the directions said to do. Sometimes you're going to need to do that to prove identities. Okay, so that's section 5.4.
That was painless.
Yeah.
I like that chapter.
Oh, yeah. You're not going to like 5.5. Okay, what 5.5 does here, and
Bring back a little bit of the graphing for some reason.
5.5, let's see. Should I stop it and start it again for 5.5, or should I
Nah.
change the
Just
name
roll
to
through it.
5.4 and 5.5?
Yeah.
All right. We'll just keep the integrity going. So at the beginning of class, I wrote this on the board. Please print things before class. Because this is very disruptive. So I made.
Sorry, I didn't realize 5.4 was so short.
Oh, I thought we were going to spend the whole time on 5.4 like we did 5.3. 5.3 was kind of long. You know. Okay, so 5.5 brings back all the stuff. So while people are still printing, you know, I think I have a link to Quizlet on D2L, and I know I use a lot of things, but this is no longer required but I made all these Quizlets for this class, Quizlet. And they help you to memorize them, and you can play little games to memorize them, but no, I'm signed up for talking. So, oh yeah, that's my username. Okay, so 1720, I have, this is a flashcard app, and I don't know, I know you haven't been using it, it's not going to be worth points, it's just too hard for me to keep track, and sometimes it's wrong. So nobody's joined this, but I have all these Quizlets that can help you on the concepts. In fact, they're like those concept vocabulary quizzes you have to do. But so it lets you play games, like if I go to this one and I want to play matching, it lets you, what you're going to make everything disappear. So you drag the answer and put it on top. That was wrong. Okay. It's a little game, and if you have a smartphone and you have your Quizlet app on it, it's free. You can play a matching game on it too. So, anyway, I'm gonna get out of Quizlet. So, I think I have the join code. You can go search Quizlet and request me to add you to allow you to add, or have an automatic join code. Okay. So the class join link, I don't know if you can read all that. See, I had copied that and posted it in D2L at one point. So I'll copy it. Oh, I know what I can do. It'll be easier just to put it in Shobi. So if you're interested in that, there is a lot you need to memorize for this class. Hopefully it's already got it. Oh, come on. Don't do this to me. It's okay. Maybe somebody else can get on my calendar. Okay, so class discussion. This is the Quizlet. It's just easier. Quizlet join code. So if you copy that link into your URL, I think you'll automatically get put into my class and you make a free account. So. Okay, because that might be helping some of you if while you're at the doctor's office. I know, we haven't had that much time. Okay, so this is, now we're going to do trig equations. And trigonometric equations are a little different. You know, a trig equation is a trig expression. Remember, expression didn't have the equal sign. With a variable. It has a variable inside the sine, cosine, tangent, whatever it is. Values that satisfy a trig equation are its solution. I mean, you've seen this before. So now now for the next part, number 2, we want to solve, we're trying to solve in number 2 with a sketch. We're trying to solve sine x equals 1/2. We want to solve that equation and we want to get all the numbers between 0 and say 2 pi. We want to get all the solutions of sine x equals 1/2 from between 0 and 2 pi. And I think you already had some math lab like this. So one way you could do it is graphically. You sketch sine x, and sine is 0 here. So we mark off our axis and pi over 2. This is y equals sine x. Pi, 3 pi over 2, and 2 pi. And 1/2, and 1, and minus 1/2, and minus 1. Okay, so sine is 0 here at pi over 6. So we got pi over, this is pi over 6, pi over 3, 2 pi over 3, and 5 pi over 6. At pi over 6, sine x actually equals 1/2. And at pi over 2, it equals 1. At 2 pi over 3, well, let's look at 5 pi over 6. It's equal to 1/2 again. Here, it's there, and then we don't need to worry about this. So it's a curve, not a straight line. Okay, there's our graph. So to solve this graphically, it says indicate with a dot where the value of 1/2 would occur for the function. So Maybe we should say with the arrow. So the function is y. Well, on the function, okay. Okay, but where is x? So I have to rewrite this problem. Okay, place a star where the solution. That's x. Okay, so the function is y. So let's use arrow. So this is where the function is a half, and that occurs when the solutions are always x values. So it says place a star where the solution star. Okay. Because I already used dots. We can use dots. All right, so the solutions, graphically, we can see that sine of x equals 1/2 when x is pi over 6 and 5 pi over 6, where x is between 0 and 2 pi, including the endpoints. So there's our solutions, and we found them graphically. So on a previous test, I had a problem just like that. You were supposed to solve graphically. Now I know you could figure it out from the unit circle, but I'm asking you to solve it graphically, so you have to do it this way. And you just show this kind of work that I showed. All right. To solve any, so that's graphic. That's the solving graphically. Solving a trig equation graphically. And I think MATLAB had that with the tangent function. Somebody asked for help with that. So even in the previous section. Now, so there's some steps for solving an equation containing a single trig function. You're going to follow these steps. You're going to isolate the function on one side of the equation. And then you're going to solve for the variable. Okay, so here's an example. We're going to solve this equation. 5 times sine x equals 3 times sine x plus the square root of 3. So first, we want to remember that the period of sine is 2 pi. So our first step is to isolate the function. So I'll write it down. We have 5 times sine x equals 3 sine x plus the square root of 3. So we want to get all of our sine x's on one side, so I'm going to subtract 3 sine x. We're treating the whole trig function sine x like a variable right now. Okay. We're going to get that by itself on one side, and we get 2 sine x equals square root of 3. Now we divide by 2. So sine x equals the square root of 3 over 2.
Now, would you take that further and say pi over 3? Or,
Yeah, we're going to do that on the next slide.
okay.
Okay? And we have to find all the values, not just pi over 3.
Okay.
We have to find all the values where this is true, or the next page here. We're going to do part B. And now, some of you had answers like this on your last test. I don't remember seeing something with ends in it and stuff, but, well, maybe it was just for domain and tangent and stuff people use in N, which is okay. Solve for the variable. So again, we had sine x equals square root of 3 over 2. So you do have, it is at pi over 3. You're right. At pi over 3, we have 1/2 square root of 3 over 2 on a unit circle. This is kind of what I meant by sketching the unit circle. You don't have to put all the numbers in, just show where it is. This one's pretty simple, but the reference angle, x equals pi over 3, is the reference angle. Okay, and that's for quadrant 1. We have an answer of pi over 3. Sine is positive. It's positive here in quadrants 1 and 2. So where is it also? It's at, I don't know if it's at 2 pi over 3. What is it? Oh. You can, so I said or in quadrant 2, x equals pi minus pi over 3. 2 pi over 3. So you can get it from the unit circle there, or we're using reference angles. The reference angle, this is pi over 3, is always the angle with the x-axis, against the x-axis. And it's always positive, actually. The reference angle is going to be positive. But this is quadrant 2. You could just use your unit circle and find the second value.
But will that always work? Or will you like using the unit circle?
Without using the unit circle, yeah, this should always work.
No, like, can we always use our unit circle to find that, or will we have to use the reference angle?
You're going to have to use your reference angles
Okay.
sometimes too. It's going to be important that you understand the reference angle. So, so we have two answers between 0 and 2 pi. How do we write that as, it's cyclic if we keep going? So our answers are actually x equals pi over 3 plus 2. I was going to write plus or minus, but we're going to make n any integer, so 2n pi. It repeats every 2 pi. Or x equals 2 pi over 3 plus 2n pi, where n is any integer. And you won't always be asked the, pi over 3 that you know and can find on the unit circle. So you need to do reference angles. So what I did is the reference angle is pi over 3 in this quadrant. So to find this big angle, you could take pi minus pi over 3. Draw a picture, it helps to find that. So there's the reference angle. And because we were in quadrant 2, I subtracted from pi to get that. Okay, so we got all those answers. An infinite number of answers. So sometimes yes.
Why did you do the 2n pi? Like, where did that come from?
Oh, the 2n pi. Because the period, because it's a period. So I remember when I wrote the period of sine down, you probably wondered why I wrote that down. We get the 2 pi from the period. It repeats itself every 2 pi. So if you are here and you go around another 2 pi, you're here. And you can keep adding 2n pi, or n times 2 pi. Or n could be negative, so if you subtract the 2 pi, you'll be here again. So this is where we got the 2 pi was from the period. The period where it starts repeating itself is 2 pi, and that's where we got the 2 and the pi. Good question. So when we do it with tangent, the period's pi, and we'll be using n pi instead of 2n pi. Okay? Any other questions?
One more time, a reminder, when you're dealing with reference angles, how do you know whether or not to use pi or 2 pi? If you're using the whole unit circle or just...
Okay, so first I had to remember, where is sine positive?
In the first...
In the first and second
Second
quadrant. So I had, and then I drew my picture. So there's a reference angle against the x-axis, and I need to take pi minus pi over 3. So if you were in quadrant 4, you subtract from 2 pi.
Okay.
And I do it, I don't, there, in that section we had formulas for that, but I do it by drawing the picture and making sure I know what I'm subtracting or adding. Here, if the angle was in quadrant 3, you'd have to take pi plus that, but I draw the picture to figure that out.
Okay.
So instead of memorizing those formulas, draw the picture.
Alright.
But you do need to remember the reference angle is against the x-axis. The reference angle is is on the x-axis, one side of it. Okay. All right. We'll do another example. Let's do it in different colors. Let's do that. Okay. So here's my equation. So I want to get the sine by itself on one side. So I guess I decided I'd like to keep it positive, so I subtracted 3 sine x. You could subtract 5 sine x. It's just like solving the equation. Pretend like sine x is the whole variable at this point. You're getting that by itself on one side. You get minus 2 equals 2 sine x minus 1. Now I want to add 1 to both sides. to get the sign by itself. So I have -1 equals 2 sine x, and divide by 2. Sine x equals -1/2. Okay, that's part A. That was isolating your trig function on one side by itself. That was the first step. Now, again, the period, so again, we have sine of x is positive, negative, so we have different quadrants, is negative in quadrants 3 and 4. So you note that, and I drew a little picture. And the reference angle is positive pi over 6, but if you do inverse sine, you're going to get negative pi over 6. But this is, because this angle pi over 6, or negative pi over 6. But what this question doesn't say is that we want to find all, again, we want to find all x values. We want to find all the solutions where this is true. Okay, so the reference, and this is going to be true here, and it's going to be true over here. This is, the reference angle is pi over 6. The reference angle is positive pi over 6. So I'll just put this as positive. Those are my reference angles. What are these two angles? One of them's here. So one angle is going to be pi plus pi over 6. That's 6 pi over 6 plus pi over 6. It's 7
That makes sense.
pi over 6.
That makes more sense now that you showed the drawing of it, yeah.
Yeah, so always draw it,
Yeah.
okay? And we're going to write this in terms of positive angles here. We want all, and we want to use positive angles. So we're going to get all, so we're getting, first we're getting all solutions between 0 and 2 pi. And then because the period is 2 pi, we'll add the 2n pi to those. So this is one solution just between 0 and 2 pi. The other one is we're going to take 2 pi minus pi over 6. And that's 12 pi over 6 minus 1 pi over 6 is 11 pi over 6. So these are my two solutions between 0 and 2 pi. Now I'm going to write, because the period of sine x is 2 pi, we're going to write these like we did up there. So then all the solutions, let's just write x, so x is going to be 7 pi over 6 plus 2n pi, and x is also going to be 11 pi over 6 plus 2n pi. n is any integer. Okay, so this is bringing back reference angles and periods of functions. Okay, so if you have to look up the period every time you do one of these, then, you know, it's going to be, you're supposed to have the background of knowing the first test, two test material, but here. Okay, and then you may check your solutions with the calculator. You graph the left side of the equation and the right side separately. Hopefully you've done this before. And then the solutions will be the x-coordinates of the points where the graphs intersect. So, have you guys all done that on the calculator before?
Not a minute.
Not?
It's been a while.
All right, well, let's do this one. It's to check. So you still have to find your solution. So one thing is your calculator is going to give the solution to 7 times pi divided by 6 will be one solution. It's going to give decimals. Like, it's going to say this is 3.665 and 11 pi over 6. 11 times second pi divided by 6 is 5 let's just put 5.76.
Can you move the calculator over a little bit so?
Move it.
No, that way.
Oh,
To you.
yeah.
There we go.
Oh, you couldn't see it.
Yeah.
Okay. Well, these were the solutions from the calculator. That's 7 pi over 6 and 11 pi over 6. You're not gonna, those, if you just write those down on the next test, that's gonna be worth no points. Okay? Unless I tell you to, even on the part you're allowed to use your calculator, you still have to show your work. Sorry. Okay. But, okay. So we're going to check, okay, calculate. So we're going to go, the left side of the equation is sine x. Y equals sine x. The right side of the equation is negative 1 divided by 2, where you could have put. So do zoom 6. Oh, there's that straight line with sine. Oh, let's do zoom decimal. Just remember, wait a minute, did I type it in wrong? Sine x and negative a half. So when I hit graph, do I still have to change the window? Oh, pi is 3.14. So 2 pi is 6.28. Let's just start it at 0 and 6.28. See, it's not as easy as you would think, right? We want the x scale to be 1.57. Is that a pi over 2? Yeah. Y, we want to be up at maybe down at negative 1.5. Remember, sine only goes from 1 to 1. Now let's hit the graph. What did I type in? Sin x. How come sin x is the graphic? Oh, let's see. How about this? Mode. I want it in radians. Okay? I had the mode wrong. Okay, let's hit that. Ah, now I'm happy. Okay. I was like, what is wrong? See the mode. Gotta check the mode. Okay. So those are our solutions, and I've marked it off in approximately pi over 2. Okay? But I had to fix the window to see this nice graph and fix the mode. Okay? So now you can do second calc intersect. Then you want, here's the first curve. Yes, that's the first curve, so hit enter. Second curve, yes, enter. Guess. Let's guess that it's, let's just 3.2. And that's our answer. Is that what we got? Our answer is 3.665. Okay? So, and then you'd have to do intersect again, and you're going to guess the next one to be around 6 or something. And you're going to have to move your cursor when you do second intersect.
It's almost easier just to do the algebra, so to speak. You know what I mean?
Yeah, we're going to have to move this up here and hit enter. Second curve, hit enter. Guess. Yeah. And we get the answer. Okay? So that was a lot of work, but you could tell if your answer is right with the decimals. But if you just give me decimals, unless the problem only is in decimals. Okay? All right, so that was, see, I wasn't even going to show you that, and that was more complicated. So the mode had to be in, because what we were doing, the mode had to be in radians, and we had to change our window, and I changed my window to go from 0 to 2 pi, and I made my scale 1.57 because I remembered that was pi over 2 approximately. So, and then we did second calc intersect. Okay, to see the nice, we had to change our window, and we had to change the Y window too. Well, I could have left the reason it was doing funny things is that I had it in degree mode. In degrees, I was only seeing a very small part of the curve in degree mode. So, all right. So now we're going to do another one. So, how do you solve an equation with multiple angles? So we've got tangent x equals 1, for instance, or sine pi over 2 equals square root of 3 over 2. I don't know, tangent of, I think, I have on my notes that this was supposed to be 3x. For instance, if you have tangent of 3x equals 1. This is a multiple angle. There's a 3 missing there. And this is, well, I don't think I don't think that's a good example. I'll have to look back. But here, we're gonna do an example. Solve a double angle here. You solve tangent of 2x equals square root of 3. So if this wasn't by itself on one, by itself on one side. Okay? So, and it says between 0 and 2 pi. I think they made a mistake. We really want to go between 0 and pi. 3 pi. Oh, maybe it is between 0 and 2 pi. Leave it there. The period of tangent is pi, and this is an example on a page, but I don't think this is right for your book anymore. But you can find it. Let's see. So let's look at the period is pi, so let's look at in the interval 0 to pi. If you're in that interval, the only value for which tangent is positive, so you're looking at where, you're looking at tangent theta equals square root of 3. You can't move the 2 pounds toward it. You're looking at, in the interval 0 to pi, this is going to be 2 pi. The period of tangent theta is pi, but the period of this function with the period of a function with a dx in it for tangent is the period of the regular function divided by b. So, but we're going to find all the answers between 0 and 2 pi. And so our period is going to be pi over 2. Just showing you that. Okay. So the only value in this interval where tangent in the interval, that the only value for which tangent theta equals square root of 3 is pi over 3. You're gonna, so at pi over 3, again, we're using this a lot. We have a half and square root of 3 over 2. So tangent is sine over cosine or y over x. So tangent here is square root of 3 over 2 divided by 1/2 is square root of 3. I know that's hard to read. It's square root of 3 here at pi over 3. Okay, so we have tangent of pi over 3 is the square root of 3. So that means that 2x, that means 2x has to equal pi over 3. Now we can solve for x. Okay, so we divide by 2 or multiply by a half, and we get x equals pi over 6. Kind of makes sense, okay? And I'm sorry, on my notes, because tangent, I could have put, well, I did figure out the period. What's the period of this new function? So we're going to add n times this period. And if they want only the solutions between 0 and 2 pi, then that's not your answer. But if you look at the filled-in notes, you could have also done it on the previous step. You had 2x equals pi over 3, and the period of tangent is pi, so that's plus n pi. And then we could have divided everything, or multiplied everything by a half. No, we get the same thing. Those are my filled-in notes, have it that way. So you could do it either way there. You could add the n pi here, and then divide everything by 2, and you get this. So either way, or you figure out your new period, and you have to add n times your new period.
So is the answer that, or?
No, so we have to keep going. We have to find the exact answers between 0 and 2 pi. It is 2 pi. So we're gonna let n, so that was an alternate step there. We're gonna let n equal 0, and we're gonna keep going. Plug in the values of n till you have all the solutions. 0, 1, 2, 3. So when you plug in 0, you get x equals pi over 6. That's one answer. The next one's going to be pi over 6 plus pi over 2. That's 3 pi over 6, 4 pi over 6, which is, that's 4 pi over 6, which is 2 pi over 3. The next one, when you put in 2, you're going to get pi over 6 plus pi. That's pi over 6 plus pi is 7 pi over 6. And the last one, putting in 3, you're going to have pi over 6 plus 3 pi, I ran out of room, oh well, 3 pi over 2. You do that math, you can do 1/6. You love fractions, right? So you can do 1 divided by 6 plus 3 divided by 2. Math, enter, and you get 5 pi over 3. So your 4 solutions between 0 and 2 pi are pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. Those are your 4 solutions. You can use your calculator for those fractions if you want. Just leave the pi out, add and change those things to fractions, and then put the pi back in. Okay, any questions? I think that's, if you have questions, we'll at least take a long time. We're going to stop there and continue next time. But ask questions if you have them.
Any homework for next time?
The worksheet, that was Tuesday.
Okay.
And the 5 point.
And it's all 5.5.
I don't remember.
What's the
Just fine. Yeah, you should
Can
be.
you show me under test, material, tester material?
Okay, thank you.
Whatever it is.
Chapter 5, test 3 material.
That's not, so this is on,
It's right here. So, you should you should print that out and use it, get used to using that. Oh, and by the way, it does say what the names of the formulas are. Yay! Okay. It does say what that these are the half angle formulas, even odd identity, some different, so it does put the labels on. All right, well, have a good day. We're gonna finish 5-5 next time. Review for the test, the test is a week or Tuesday. Be working on your math lab, don't put it off.
I do that often.
What?
I do that often.
Oh, you put it off?
On accident.
Oh, no.
I don't know why, just.
For the most
Yeah.
part, like I just forget when I sometimes.
Okay. All right.
Can you still do late work on my math lab?
The math lab, until the final handshake.
I didn't realize when we see it
Okay, all right. Well, yeah, you can turn it in that way. Do you have your copy?
I wrote it beside it, and I sheltered it with a,
You can turn it in that way, because I have...
the one on Shogi was like super glowy, and I couldn't see it.
Okay, I'll take it that way, if you have it on paper. Thank you. I'll probably take a picture of it and grade it there, but, and I know what your page looked like before you wrote on it, so. Alright. And I think you just got confused on this, about exact, because you started with,
I did have it.
and then you erased it.
Yeah, I don't know why.
You just got confused, the exact integer was pi.
See, if you look behind it, I did write pi over 6 the first time. And then I don't know why.
And then it's right pi, I don't know if that's pi over 4.
It really is. That's not
Okay. All right. Do you understand this better?
I don't think these are right, but
No.
this one just showed my.
Because like on the first one, I felt
But did you change the answer though?
No, I did not change the answer.
Oh, that's a pi. I thought that was a 7 over 7.
Oh, no.
This is a pi over 3. Oh, yeah, that's
That's a pi
right.
over 2.
That's right. That's right. And you
Okay.
can put it in your calculator, cosine inverse of cosine of negative pi over 3 if you have it in radian mode, not degree mode. And you'll get pi over 3.
Pi over 3, okay.
And you can maybe divide it by pi and see that it's 0.333 approximately, and figure out that it's pi over 3. But,
Okay.
so you can actually put, and this is very close. I think it might be negative.
Oh, man. Okay.
Negative 3 pi over 7.
Okay.
Okay? Because tangent, well, okay, we got 4 pi over 7. And then tangent of 4 pi over 7 is going to be negative in the second quadrant.
Okay.
And then we're going to have to, the reference angle is 3 pi over 7, but it's got to go down
Oh,
here.
okay.
And tangent is, because tangent has to be negative, so it's a negative.
Alright.
But, yeah, I see what you did.
And my 7s, they have the, I know that pi kind of looks like a 7, but my 7s usually have the line.
The line through,
Yeah.
thank you. Uh-huh.
Have a great weekend.
You too, thank you.